Hello children, welcome to AIMS India's online classes. In today's class, from mathematics subject, factorization topic we are going to continue. Already we have completed some concepts children in our previous videos. So up to where? Up to this factorizing trinomials, this topic finished. And second degree expression having more than 3 terms, how to factorize them, that topic also completed. Some examples we have discussed, and factorization of some expressions which can be converted into quadratic expressions, though they are not directly quadratic, but we can convert them into quadratic and we can factorize. That concept also finished. Now children, the last concept what we have is the HCF and LCM of polynomials. So how to find the HCF and LCM of polynomials? So already we are familiar with this concept children. HCF means highest common factor, highest common factor, or it can also be termed as GCD, greatest common divisor. LCM means least common multiple, least common multiple. About HCF and LCM, already in our earlier classes we have learned, but here these two concepts we have to apply for the polynomials. Till now we might have applied for the normal numbers children, but here we are going to apply for the polynomials. So if they give 2 or more integers, how to find their HCF, how to find their LCM, that we know already. But now we are going to calculate HCF and LCM of polynomials. So here children, normally what is a divisor? A polynomial b of x is a divisor of p of x. Then d of x is said to be a factor of p of x. Factor of p of x means if you have one equation, one minute children, I'll change the pen color. If we have one equation p of x, we have a equation p of x. It is divisible by the polynomial d of x. Then this d of x is called as divisor. D of x is called as divisor. So here, if it completely divides, then it is called as a factor. And we will get the quotient. Let it be q of x. The quotient will be q of x. If it completely divides, remainder r will be equal to 0. So a polynomial d of x, if it is a factor of p of x, then it is called divisor of the polynomial. Then p of x can be written as p of x equal to divisor into quotient q of x, where q of x is some other polynomial which is considered as quotient. So p of x equal to d of x into q of x. Like this we can write. So here d of x is termed as divisor. So common divisor. Suppose we have two equations, p1x and p2x. Like this we have two equations or two functions. Suppose if the polynomial d of x, it divides both p1x and both p2x. It is a factor of both p1x and p2x. So then this divisor is called as common divisor. A polynomial d of x is said to be a common divisor when d of x is factor for both p1x and p2x. Means p1x can be written as d of x into q1x, where this is the quotient in first case. p2x also can be written as d of x into q2x, where this is the quotient in second case. If d of x, here also it is a factor, here also it is a factor, means d of x is common factor. D of x is common factor for both different equations or functions. So then it is called common divisor. Common divisor. So first let's see HCF of two polynomials, children. The HCF of two polynomials P1x and P2x is the common divisor which has highest degree term coefficient is positive. Means the whatever common divisor just now we have discussed, so that common divisor for both the equations is considered as their HCF. But that common divisor should has highest term coefficient positive. Highest term coefficient positive. Suppose find the HCF of, here they have given example, find the HCF of this total combination 4x minus 5 into 2x plus 5 and this total combination 4x minus 5 whole cube into 3x plus 7. This is P1x, this is P2x. For these two, what is the HCF? Just by observation we can tell. Here 4x minus 5 is common. Means 4x minus 5 is the only common divisor out of these two polynomials. And this 4x minus 5, here x power 1, here x power 0, highest power is x power 1. For that coefficient is 4, which is positive. Means 4x minus 5 is common in P1x and P2x, and in that 4x minus 5, highest power is x power 1. Before that coefficient is 4, which is positive. So this is considered as HCF. So 4x minus 5 is the HCF of given polynomials. So just by observation also, we can identify the HCF of the different polynomials. But for all the problems, we cannot tell like this. In this method, we cannot tell. So for that also, we have a special method, HCF by factorization method. So here, children, what are the steps here means? So express given polynomials P1x and P2x. First one to be taken as P1x, second one to be considered as P2x. Like that, we have to express the polynomials. Next, find the HCF of numerical factors of P1x, P2x. First, we have to find numerical factors. Then, step 3, find the common factors. Means common factors of variables of P1x, P2x of highest degree. First, numerical factors we have to find out. Next, common factors in terms of variables we have to find out. In step 2, we got numerical factors. In step 3, we got common factors. So the product of all such common factors which we found in step 3 and all numerical factors which we found in step 2, that product is considered as HCF of P1x and P2x. So numerical factors we have to find out, then common factors we have to find out, the product of all such common factors and all numerical factors, that product is considered as HCF of both P1x and P2x. Let's try to understand by one example, children. So find the HCF or GCD of this 22. Is there any print mistake? It is, children. 1 minute, children. I think it is 22 into x plus 1 whole square. 22 into x plus 1 whole square. And is it 22 into or 22x? I think it is 22x into x plus 1 whole square, children. And it is 36x square into 2x square plus 3x plus 1. So let us assume first one as P1x, 22x into x plus 1 whole square. This can be written as 2 into 11 into x plus 1 whole square means x plus 1 into x plus 1. Like this we can write. Second one, let us assume it as P2x, 36x square into 2x square plus 3x plus 1. Plus 36 can be written as 2 into 18. Again, 9 can be written as 2 into 9. Again, 9 can be written as 3 into 3. Means 2 into 2, 3 into 3. Means 2 square, 3 square. This 36 can be written as 2 square into 3 square into x square. Inside the brackets we have 2x square. 3x can be written as 2x plus x plus 1. Because for factorizing this, we have written like this. From these two terms, 2x we can take common. So here x plus 1 will remain, which we have learnt already about that. From these two, there is nothing common. 1 we can take common. Inside the brackets, the value will be same. Again, x plus 1 we can take common. Then here 2x plus 1 will remain. 2 square as it is, 3 square as it is, x square as it is. So this can be written as like this. So now this is the P1 value. This is the P2 value. If you observe all this, what are the common numerical factors? Here also 2 is there. Here also 1, 2 is there. Actually 2 2's we have, but 1, 2 is common. So numerical factor which is common is 2. Only 2. And what are the variable factors which are in common? 1x is here. In x square also, actually x square means x into x means 1x is common. So 1x is common. 1x is common divisor. And here x plus 1 is there. 1x plus 1 is there. Means 1x plus 1 is common. So 2 is common. X is common. X plus 1 is common. The product of all this, 2 into x plus 1. 2 into x into x plus 1. This is the HCF of the given two expressions. So like this, we can find out the HCF, children. Next, children, we have LCM. LCM of polynomials. 1 minute, children. Next, children, LCM we have, children. So LCM of 2 or more polynomials is the smallest polynomial of the least degree that contains all the factors of each polynomial. So we have to write one smallest polynomial which contains all the factors of each polynomial. All the factors of each polynomial. That combination is called LCM. You can understand better by problem, children. So to find LCM of 2 or more polynomials, what we have to do means we have to find the factor of each polynomial and take the product of each factor the greatest number of times it occurs in any one factorization. Let's try to understand with the example, children. So while doing LCM, we have to follow some steps. So the given two polynomials, first one take it as P1x and second one assume it as P2x. Next, if a factor, step 2, if a factor is common, we take that factor which has the highest degree in P1x and P2x. Suppose one factor x is common in P1x and in P2x. In P1x it is there and P2x it is there, one factor. But we have to take it highest degree. Highest degree in P1x, if it is highest degree, we have to take that, or in P2x, if it is of highest degree, then that we have to take. The common factor where it is having highest degree, that we have to take. Next, let's see the example, children. Find the LCM of this expression and this expression. So here a square minus 12a plus 35. Here a square before coefficient is 1. So AC, product of AC is 1 into 35, which is 35, to be split into two terms, so that product equal to 35 and middle term, sum equal to middle term. What is middle term? Minus 12. So we can take minus 7 minus 5. So that sum equal to minus 12, product equal to 35. So the middle term can be split as minus 7a minus 5a. Minus 7a minus 5a. If you take a as common, a minus 7 will come. Here minus 5 as common, a minus 7 will come. Again a minus 7 common, a minus 5 will come. This we have learnt already, children, by that method, by factorization method. So this is equal to a minus 7 into a minus 5. So here a minus 7 into a minus 5. A minus 7 into, some steps are wrong, children, here. So this one directly equal to this one. Okay. Next. Actually here we can write a minus 7 into a minus 5. Next, this one, a square minus 8a plus 7. Minus 8a can be split as minus 7a minus a. From first two we can take a common, a into a minus 7. From next two there is nothing common, 1 we can take common, a minus 7. Again a minus 7 common, a minus 1 will come. So this is equal to second one. This is the first one, this is the second one. So here a minus 7 common, that we can take. A minus 5 present in only one polynomial but not present in another polynomial. Means in one polynomial it is occurring one time, in another polynomial it is occurring 0 times. Means highest number of time, one time occurred in one polynomial. So we have to consider. It may not be present in both, but here 0 times it is having, there 1 time it is having. So highest number of times it is present in first polynomial. So we have to take it. While taking the LCM, we have to consider it. Next, a minus 1. It is in second polynomial, but it is not present in first polynomial. Means in first polynomial it is 0 times, in second polynomial it is occurring 1 time. So that also we have to consider. So a minus 7 for this a minus 7. So a minus 7 we have taken common. A minus 5 is in first polynomial, that we have taken. A minus 1 is in second polynomial, that we have taken. The product of all is called as LCM. That is the least common multiple of both the polynomials. Next, one more example, children. Find the LCM of polynomials 16 minus x square and x square plus x minus 6. So let us assume this has P1x, 16 minus x square. If we take minus common, inside we can reverse them, x square minus 16, because we have taken minus common, So whenever we have a difference, if we take minus common, the signs will change inside the bracket. Now x square minus 16 means x square minus 4 square. It is in the form of a square minus b square, which is equal to a plus b into a minus b, which is equal to x minus 4 into x plus 4 minus outside. Second one, x square plus x minus 6, middle term. We are splitting it into 3x minus 2x by factorization method. In first two group, x is common, x plus 3 will come. In next two group, minus 2 is common, x plus 3 will come. Again, x plus 3 is common, x minus 2 will come. Now, while taking LCM of both P1x and P2x, x minus 4 present in first polynomial but not in second polynomial, we have to take it. X plus 4 present in first but not in 2, we have to take it. X plus 3 present in 2 but not in first, we have to take it. X minus 2 present in 2 not in first, we have to take it. Minus also present in the first one, so that's why minus also we have to take. Minus means minus 1 is present in first one, we have to take it. So this is the least common multiple. This is the multiple of both first one and both second one. Both first one and second one. And the relation, children, the relation between HCF and LCM is, suppose if n and m are two numbers, n is a natural number, m is a natural number, and n into m is called product of numbers. Product of numbers, n into m, is always equal to product of their HCF and LCM. Product of two numbers always equal to product of their HCF and product of their LCM. Or if you want to find LCM, LCM of two numbers equal to product of numbers by HCF of numbers. Or we can write reverse also. HCF of two numbers equal to product of numbers by LCM. Like that also we can find. So this is the relation between them. If P1x and P2x are two polynomials, how to find their LCM? Product of two polynomials by their HCF. Like that also we can find out. So that's all, children. So all the concepts are completed. So let's solve problems in our next video. So thank you for watching our video, children. Please subscribe our channel and press the bell icon for receiving latest updates. So you can also visit our website, children, www.aimstoday.in, for information regarding other online classes, quizzes, worksheets, activities, English classes, coding skills. Thank you, children. Have a good day.